first thing I need you to do is take your bright colored sheet of paper out for stats. Okay? And I'm going to give you good news and bad news about it, I guess. Does everybody have their stats bright colored sheet of paper? I have a few extras. Just in case you're sitting there going, did you give me one of those at the beginning of the year? I don't remember getting one of those at the beginning of the year. Yes, we're good? Everybody's cool? Ah, nice. Okay, when I first started talking about the stats portion, the very first day, I believe, I started talking to you about finding means, and I took ages from people in the rows, right? You guys remember that? It was just so cool. So let's say I'm doing that again. So I'm going to take a couple ages, I'm making them up. Somebody's really old. I put a 51 last time, but I'm not going to do that again. 1, 2, 3, 4, 5, 6, because you all called me an outlier. I was. I'm okay with that. Okay, as this is, we are going to find the mean. In words, how do we find the mean of this? Add them all up, divide by 1, 2, 3, 4, 5, 6, 7. Okay? Everybody's cool. What's the formula that you would look at on your bright colored sheet of paper that indicates that's what you need to do? First of all, is it grouped or ungrouped? Good question. It's ungrouped. We know that because it doesn't say your ages are from 10 to 20 and 20 to 30. We delved into that for the last couple weeks, but this is just definitely an ungrouped data set. So the formula is X bar. Can we remember that? X bar means what? The mean. And what does it want me to do when it's ungrouped data? The summation of x's divided by n. Perfect. So as you know it, you can find the mean of this. So I'm going to let you do that. I'm going to take a roll real quick. I'll step back in and tell you the new stuff. Even? Yeah. Hey. Well, shoot. I wanted to have another number in there, but that's okay. I wanted like 16.5. All right, whatever. I'm just too good today. Okay, so now, what I'm going to teach you is something called coding. So coding, I don't even know why they call it that, because it's not the coding that you would learn in Miss B's class. It's not that kind of coding. It's actually taking your numbers and manipulating them a bit so that it makes your data set a little easier to work with. When I have 17 numbers, 17, like 15, 16, it's really not a big deal. You don't have to code. But if I have 200 sets of numbers, like I have 200 numbers, and they're all in the hundreds, then you would use this coding, okay? So let me explain what coding actually is. This is not on your bright colored sheet of paper. I apologize. It's something you have to have in your head. So that's what makes this particular lesson difficult. However, it's not. If you can keep it in your head, you're good to go. Okay, so what this particular formula says is I'm going to do the summation, and I'm going to give it to you, and then I'll just explain it to you, of this. Again, completely new. I would assume none of you have ever seen this. Okay? It's called coding. Why is it C-O-D-I-N-G? I don't know. Honestly, I have quite a bit of math behind me. Like I have a degree and a master's in math. I have taken, if you really want to talk about it someday, it's like exciting how much math I've taken. And I never have talked about coding ever before. So this is something that they truly like to put on the exam at the end of the year. And it's an easy set of points if I can make it easy for you. Okay, so what does coding do? Again, it's useless waste of time for 7 numbers that are in their teens, okay? You wouldn't use this process. However, I wanted you to be able to wrap your head around it with something easy, okay? So what coding says for you to do is take a number, a constant number, that you are going to subtract from every single one of your numbers. So if it's in the teens, you probably would subtract a consistent number 10. If you're looking at something in the hundreds, like if you went from 101 up to 920 and you had 50 numbers, you probably would subtract 100 from it. It depends on what you're looking at. So a constant number. Never am I going to say, figure out what number you have to subtract. That's always kind of given to you. So what this says is, if you take a constant number, I'm going to take a 10. if I take a constant number from all of these guys, so let's go ahead and do that. What do I get? I get a 5, a 6, a 7, a 5, a 4, a 9, not a 9. A 9, that's not a 9, a 6, okay? So if I take a constant number, in this case I took the number 10, okay? If I asked you to now find the mean of this, how would you go through that process? You would add them up, and then divide by how many, the number 7, and you figure out what your value is. So do that for me real quick. Add them up and divide by 7. Yes?
Is that 4 supposed to be 9?
Yeah.
You just skipped 9. You just skipped 9.
Is that what I did?
Yeah, you skipped 9. So that 4's supposed to be
I
there.
had a 9.
Yeah.
And then I skipped a 9. Holy cannoli, what's going on in this brain right now? There it is. Ah!
What just happened?
Oh, that's surprising. So early in the morning. All right, now find the average of these 7 numbers. I couldn't even count the 7. Oh, Lordy. Average, your mean, is 6. What constant number did I subtract from every one of those numbers? 10. If I add 10 back to this average, what do I get?
16.
And I get the same thing I should have. So what it's saying is if you consistently take the same number off, you find its average, you add that number back in, you're going to get the average that you should have in the beginning. Let's look at this formula. It's the summation of x minus a. What does this mean? That means all your x's are going to have a certain number taken away from it. The one we just did was a 10. Are you guys cool with what I just said? So you're going to take 10 off, 10 off, 10 off, and then you do what with those numbers? Well, you add them up. And then what do? You divide by however many. We had 7 numbers. If I did it right, we had 7 numbers. And then what do we do to get to our original mean? Add what back in?
The number that you used.
The number in this case was a 10. That is your new formula that you have to have memorized. It's not horrible. Okay? Did I lose anybody or are we cool? Feeling good? Okay. So most people feel really good about it. Why did I want to have like 16.3? Because what would have come up over here? 6.3, and then, oh, I added 10. It seems like much more exciting than this, but anyway, we got what we got. Okay, so here's what we're going to do. I'm going to actually show you a kind of question that you're going to utilize this for. Now, don't get excited on me because this is where people went, what the heck are we doing? Okay, so the weights of luggage carried on a flight by 97 people or passengers is going to be given to you like this. Okay. I'll let you write it down. We're going to talk. Giving me here. Let's kind of discuss the weights of luggage carried on a flight by 97 passengers. You know the one that you bring on and you put overhead, whatever, right? Does it really matter in real life how much the luggage weighs that you bring on? Yeah. It actually does, right? Because a plane can only take so much weight, and so they figure that out as you go. All right, are we cool? So, the weight of luggage carried on by a flight of 97 passengers. What is it they're giving me here? What is this information? Can somebody explain what this is here? So they're coding it. So what does that mean? Like in words, what is this representing? How many pieces of luggage do I have? 97. What am I doing with each of those pieces of luggage? Subtracting 5. And then when I add them all up, what do I get for my result?
314.
Does that make sense? I have 97 luggage, I subtract 5 from every one of them, I add them up, and there's my answer. Cool? Are we good? What's happening with this information that they're giving me? I have 97 pieces of luggage, I'm doing what with it? Subtracting 5, then doing what to the number? Squaring it, then doing what? Adding them up, and that's my result. Does everybody see that? I think that's why I went wrong in second period, because they're like, what does that mean? So, is everybody good? We're good. 5 off, 5 off, 5 off, 5 off, add those puppies up, I get 314. Okay, now, having said that, this wants me to find this. Do you recognize this summation of x? Where do we have that in what we're doing?
Group data.
An ungrouped data, in what formula?
To find the mean.
The mean, right? So this is the original. Would this represent something that had 5 pounds taken off every one of them? No, this is the original ages that had like the 10s back in, right? So those we're trying to find is, now I want you to put those 5s back in and find the sum. We don't even know how much the individual numbers cost, however, we do have 2 sets of formulas that we can use. It's like taking 2 equations with 2 unknowns and solving, and that's really what we're gonna be doing, yes.
Couldn't you just multiply however many there are by however many you took off and then add that to whatever's given?
So you don't know, well, yes and no, but we have, like, what's my formula? So yes, eventually, but what's my formula that we're gonna be utilizing?
The coding formula?
Not yet, right? Well, yes, we are doing both. But this formula right here is that, right? So what do I need in order to be able to solve for the summation of x? I need 2 other things here. What do I need? I need n. Do I have n? I absolutely do. How many is it? 97. Do I have the mean?
Yes.
Not yet, but can I find the mean? Yes, I can. Why? Because I have this information. So we're gonna find this information first and then plug into here. Let me show you how that works. All right, so the coding one that I told you that you have to know is that. Are we cool so far? So we're gonna use the summation of x minus 5 is equal to 314 to begin this process. So I'm gonna start plugging in what I know here. X bar, I don't know. However, do I know the summation of x minus some number? And what is it? In this case, it's 314. I'm gonna write it out slowly. The summation of x minus 5, right? Divide by n. And then what am I gonna add to the back end of this? The number 5. Did everybody see why 5 came up? So I'm gonna add a 5. So far, so good. So what can I fill in for these little things that I do know? In other words, what is the summation of x minus 5? It's 314. How many pieces of luggage do I have? 97. I'm gonna add 5 back. That gives me x bar. So, crunch your numbers with your calculators, s'il vous plaît, if you please, and then go ahead and tell me what that is. And what does x bar come? 8.24. Thank you. Everybody cool with that? We took 314 divided by 97, added 5 back, yay, life is good. Yes? Okay, so now that we know the mean, right, and we're trying to solve for the summation of x, do we have pretty much everything we need to be able to solve for that? Well, we sure do. We have a mean, right? Summation of x, we know 97. Okay? Now, we gotta talk, right? So, do you agree with me, yes or no, that this is the mean with all the 5s taken off?
No.
Does that make sense? This would be the mean with all the 5s taken off. Like all the 5s are gone. I mean, this is like, right? But what would I do is I added my 5 back on to get this mean. So in actuality, we're going to use the real mean, the one with the 5s back on, to find this. And it'll come to light why you're going to need to distinguish between the two. So my actual mean is 8.24. Can you solve for the summation of x? And what do you get? Anybody? 7 what? 799? Point what?
They should be even if you just leave it as 2 seconds.
Oh, okay, gotcha. Okay. So 799-ish. Depends. What I always say is, when you're doing these problems, don't round until the very last step. Round at the end. Don't round. At least leave 4 to 5 decimals, and then at the end round. So I'm not certain where that came into play, but make sure you take care of that. Okay, anybody have any questions so far about that? Now the next one is where it gets a little bit tricky. So when they give me the next bit of information, the summation of x minus 5 squared, where does this come into play? Where would we use when we take the 5's off and square the answer? So what formula am I talking about here?
Standard deviation.
I am talking about standard deviation, right? So give me the original standard deviation. Remember, we use the second one. Standard deviation is equal to what?
Divided by n
times x bar squared.
Okay, does everybody see that? Everybody's cool? Okay. So, everybody agree that this x is the reference of the one before the 5's were taken off? Does that make sense? There's no 5 taken off here. However, what they're giving me is the one with the 5's taken off. You guys cool with what I just said? So what I'm going to do is I'm going to kind of alter this and figure out what I can plug in here. So I'm actually going to do this with the 5's taken off. And so the mean that I use has to be the one with the 5's taken off. Okay? 5's are taken off. What would the mean be with the 5's taken off? Yes?
Plus 5.
It would be what?
Plus 5.
So this is with the 5's on, and so this is with the 5's on. What would the mean be with the 5's off? 3.24. See, this is with no 5's, right? This is with the 5's taken off. This is the mean with the adding of the 5's. Do you see the difference? That's why I kind of wanted you to be able to distinguish. 5's are gone, mean, add 5's back in, mean. So what is this mean going to be? What does that become if I took 5 off of that mean? 3.24. All right. What is the summation of x minus 5 squared? They gave it to me, right? What is that? 1623, if I can see it. Okay. What's my n? How many? 97 luggage. Minus 3.24 squared. All right, if you don't mind, tell me what you get for your standard deviation. Anybody get an answer for me? And did you already take the square root of it? Okay, I need the square root gone.
2.5.
2.5. That's what I remember earlier. Okay, so everybody kind of plug it in your calculator and see if that's what you get. Are we cool? Everybody feeling good about it so far? What's the one hiccup people can come into? Is forgetting to use the correct mean. Okay? Are we feeling okay?
Yeah.
All right.
And that's your x2, right? Your
So that's my
summation.
standard deviation.
Okay. But is that like your summation of x?
We're gonna find it now.
Okay.
Yeah. All right, everybody so far so good? Now I'm gonna tell you the one thing that makes this kind of easy. The standard deviation, whether I take 5 away or whether I have 5 in, is gonna be the same. Because what a standard deviation is, how far away from the mean are you? So the distance is going to be consistent, regardless if I have the smaller mean or the bigger mean. So standard deviation is standard deviation. So that is now a given, yes.
Could you have done for the standard deviation, the summation of x that we found, the 799 squared? Or no?
No, there's a definite difference between just the plain x and the x squared. Because at that point, you would have taken each individual x and squared them. Yeah. So the good news is that this standard deviation is 100% the standard deviation for the next piece. So the last part of this question is, it wants me to find this. Remember, this was my first piece, this is my second piece. So the formula that I'm gonna use to find this is still the standard deviation formula. It's summation of x squared divided by n minus the mean squared. So the question I ask you is, I have the standard deviation, yes. I have n, that's 97, right? And which mean am I gonna use now for this? Which mean would I use? Is it the one with the 5's taken off, or is it the original mean? It's the original mean. Tell me why.
Because you're not using the x squared minus 5.
I'm not looking for x squared minus 5 anymore. I'm looking for the original puppy, right? So I have to use the original mean. Which mean am I referring to in this question? What's the number? The mean is this guy right here, right? 8.24 with that 5 added in. So I'm going to plug in what I know. Standard deviation is standard deviation. We're looking for the summation of x squared. We know there's 97, and we're going to use 8.24 squared. Are you able to solve there for the summation of x squared? Yeah, might be a little bit of math action going on. Some people had issues earlier just kind of remembering how to pull that together. What should you do both sides first? Okay, everybody's feeling good about that? So what's 2.5 squared? 6.25. So 6.25 equals the summation of x squared over 97. And what's 8.24 squared? 67.9. The answer is no, they wouldn't, because the square root has two things that are added or subtracted in between. If they were a string of things multiplied, yes, you could do what you just said. But because there's addition and subtraction in between, you can't individually square root them. Alrighty? Okay, now what do I do to both sides? Add 67.9 to both sides. So what do we get when we do that?
74.15.
Thank you. Summation of x squared over 97. Now what can we do? Multiply by 97. And what do you get? I feel like that's what I heard. 7,192.55? Yes, okay. So what is that? What is this 7,192.55? What is it representing? Well, it's 97 people's luggage, right? Their weights. What am I doing with their individual weights? Squaring them, and then do what? Doing what with them? Adding them up. That's what this number is. Okay? So what do you guys think? Bad, ugly? Yes.
So for the first standard deviation, why did you use the mean with taking out the 5?
Because the summation that I had was with the 5's gone. So I have to be consistent. I'm gonna use the ones with the 5's gone again. So if they tell me the value with the 5's gone, I gotta use the mean with the 5's gone.
Okay, so it's because it's subtracting 5.
Uh-huh.
That's okay.
Yeah. What do you guys think? Yes, no, maybe so? So I'm gonna tell you that that's really like the whole umbrella of the lesson that I'm gonna teach this week. We're just gonna do lots of problems. So if we feel cool about, I'm gonna do a problem up here. We have like 3 or 4 I wanna do together in class. I'll tell you which homework problems that I uploaded you have to do, and then that's kind of it. So that's the new part of today's lesson, and that's all. I kept that for last for multi-purposes. I think it's easier to teach just in itself, and then I think it might be a good test at the end of the day. I think it might be a good test. So, all right, are we cool? Let me give you an actual problem. Okay. Do we like it? No. Oh, tell me straight up you hate it. All right. Well, maybe after you do a few, you'll like it. I don't know. I can't twist your arm. let you write it, we'll talk about it. 36, 60, 36, I don't know what you're talking about. This guy,
No, the x minus 3. Oh, that's a 6.
36. This one? That guy? 36. It's really bad handwriting. 24 people were encountered in the streets, and somebody asked them, how much money do you have in your pockets? Sounds like something I wouldn't be divulging in the middle of the street. But anyway, how much money do you have in your pocket? So what does this mean? What does this mean? If you took $36 away from each person's amount of money in their pocket, the summation was negative 60. What does that tell you about the people? They're broke. They're teachers. All right, are we cool? So far, so good? Okay, so what does this mean? Every x subtracted 36 and squared gave me 227. Still a pretty small number, right? We feeling okay? So this particular question says, I want you to use this information that I just gave you to find the summation of x and to find the summation of x squared. And I'd like you guys to try it with each other, see how you do. The minus 36 equals negative 60. Do you guys agree that's the coded one? In other words, they took 36 off of every x. So my x bar is equal to the summation of x minus a divided by n plus a, right? So in this particular case, x bar is equal to negative 60 divided by 24 people, and then I'm going to add 36 back. So what did we get for our x bar here?
33.5.
33.5. Sweet. Okay. Using that x bar, I need to find the summation of x. Is everybody feeling good so far? Okay. So I know that x bar is equal to the summation of x divided by n. I know n is 24. That hasn't changed. And do you agree that we're looking for the x bar that is the full x bar, not with the 36 taken off?
Yes.
So what x bar am I going to use here? 33.5 equals the summation of x divided by 24. So summation of x is equal to 804 is correct. How do we feel about that? So far, okay. Excellent. Okay, so now the next part that they give me, it has to do with standard deviation. This is the standard deviation that has the 36 taken away. Are we cool? So the standard deviation is equal to, it's the summation of x, in this case minus 36 squared, divided by 24, and then minus. What mean am I looking to use? I'm looking for the mean that had those 36s taken away.
Negative 60 over 24.
So it's just this. Right? It's just that piece before I added the 36 back. So you guys told me it's negative 2.5?
Yes.
Yeah.
So what I found earlier is that people forgot to square the negative 2.5. In other words, they took the two negatives and made it positive, and that's a no-go, right? Because you're squaring first, MDAS tells me that, and then subtracting. If you had a mistake, that might be where it went, where it happened. Okay, so this is 227.76 divided by 24, and then minus, what is that, 6.25?
Yeah.
Okay. What happens, what is this standard deviation? No worries. What is this standard deviation? Does anybody have it? 1.8. All right, how do we feel? Yes, no, maybe so? Okay, a standard deviation is a standard deviation. I don't care if it's the big one where I don't have the 36 gone, or the small one where the 36s are gone. Standard deviation is going to be the same. So now I'm just going to start to solve. 1.8 is equal to, and it's the summation of x squared that I'm looking for, divided by 24, minus, which mean am I going to utilize? Tell me why.
Because it's like the whole thing with the 5.
The whole thing with the, I say 5s too, with the 36 is still in, right? So 33 33.5 squared. So now, when you crunch those numbers and you start to solve, you would, I think where people started to kind of go south, they forgot to square both sides. So square both sides, 1.8 squared, whatever that turns out to be. I'm going to add 33.5 squared to that. And that's equal to the summation of x squared over 24. And then multiply that answer by 24. And what does your final result turn out to be for the summation of x squared? 27,011.76 is correct. So what do you think? Yes? Good? No? Yay? This is awesome? All right. You won't go that far? I won't go that far. Now, let's talk for a second, guys. So, last year, on the Aice exam, there were people that earned a total of like 2 points on the stats exam. Like, 2 points. How many points do you need at the end of the year, approximately, to earn college credit? Like 41-ish. Last year they needed 27. So, on the normal year, it's about 41. Now, you've seen 2 full sections of the 6 of stats, to include representation and all that. This right here that you just did is a 5-point question. I can't wrap my head around how the 2 points happened for some.
Do they get your concept right if you get part of it right?
Yes, yes. So I can't wrap my head around it. So we just have to know it, not just for the test, but know it, okay? How do you guys feel about this lesson?